We are going to continue on page 15, so simplifying radicals. This is what we did on Friday. If for whatever reason you were not here Friday, I would leave some room to get caught up on the notes, and that video will be posted along with this one in Google Classroom today. Okay, so on Friday we talked about perfect squares. Can someone remind us what a perfect square is in their own words? What is a perfect square? Sophie? Okay, so a number multiplied by itself. So give me an example of a perfect square. And the square root of 16 is 4. What else? Give me another one. 25. What's the square root of 25? 5. So 5 times 5 gives us 25. What else? 100. What's the square root of 100? What about the square root of 196? Do you have a calculator? Plug it into your calculator. I see calculators on desks. 196? Square root of 196? 14? Okay. What about the square root of 225? 15. Square root of 400? 20. Okay, so some of them are perfect squares. We also dealt with problems that were not perfect squares. Remember, we created a factor tree. We circle our pairs. What happens with the pairs? What do we do with the pairs? You multiply them together, and then where do they go? On the outside. And what stays on the inside? The leftovers. What if I have multiple leftovers? What do I do with them? Multiply them. There we go. And why am I multiplying? Who remembers what I said on why we're actually multiplying when we put them back in the square root? So we divided when we broke it down, and the inverse of division is multiplication. So to put it back in, we're going to multiply. Okay, we also talked about tenths, hundredths, and thousandths and rounding. So I'm going to just give you one to kind of get our brains going again, because we seem to be on a slight struggle bus this morning. Huh? Yeah. Okay, why don't you guys try the square root of 32. So I want you to find the square root of 32 in simplest radical form, and I also want you to tell me what it is to the tenths, the hundredths, and the thousandths. So simplest radical form, and then to the tenths, the hundredths, and the thousandths. What can I multiply to get 32? I'm going to break it down. 8 and 4. Okay? Or 16 and 2. That one's fine also. I'm going to keep breaking things down, and I get 4 and 2. Did anyone stop there, or did you keep going? You kept going? Okay. 2 and 2 and 2 and 2, right? So just so we don't reuse them, I'm going to cross out what I broke down. And do we have any pairs? I have a pair of 2s and another pair of 2s. 2 times 2 is 4. Do we have anything left over? A 2. So that 2 stays inside. Yes, Tori. Okay, so that's what I was just going to say. So if we broke down 32 and you got to 8 and 4, right? And you started to break down 8 and you got 4 and 2, do you see a pair? I see a pair of 4s, right? I'm not going to use that 8 because I've already broken it down, but I see a pair of 4s. If I already have them, then they can come out and what's left over. Okay, so this is known as prime factorization when you have it completely broken down into prime numbers. Does anyone know what a prime number is? Good question. Prime number. What's a prime number? So I told you 2 is a prime number. No one. Not one soul.
Okay, well, but there's a definition. Because they're not all those. They're close. What's the definition, anybody?
Okay. You guys are killing me today. It can't be broken down any farther, okay? Can we add to that? Okay. So the formal definition of a prime number is a number that is divisible by itself and 1. Okay, so a number that is only divisible by itself and 1. So 2 is a prime number, 3 is a prime number, 5, 7, 11, 13. Okay, so a number that is only divisible by itself and 1 is the definition of a prime number. So this again is prime factorization when we have all prime numbers. Here we found a pair earlier, and so I don't need to break it down. If it helps you to break it down, then you do you. Okay, either way is fine. If I want this to the nearest tenths, what did you get? What is this to the nearest tenths? The square root of 32. 5.7, okay. What is it to the nearest hundredths? 5.66. And to the nearest thousandths? 5.657. So your full decimal was 5.6568. That's really all I need. So the 5 rounds the 6 up to a 7 for the tenths. The 6 rounds the 5 up to a 6 for the hundredths. And the 8 rounds the 6 up to a 7 for the thousandths. Okay. Is our brain refreshed? We're okay with this?
See, this is what happens when you let your dog lick you in the mouth.
Okay. I need more room, so I'm going to flip it. I don't even know where to go. Okay, what if I give you something that looks like this? Oh boy. Oh boy. Okay, so let's focus. The square root of 16a squared. We're going to look at this as 2 separate things. Can I take the square root of 16? Yes. What's the square root of 16? 4. Okay? So I dealt with the number. Everyone okay with that? What does a squared mean? Like if you were to explain, what does it mean though? A times A, right? It means A times A. Does anyone see a pair? Yes. What did we do with the pairs? We brought them out, right? Is there anything left over? Nope. So our answer is 4A. Because if I square 4A squared, guess what if I square 4A, guess what I'm going to get? 16A squared, right? Because 4 squared is 16. A squared is A squared. Okay. So what about the square root of 36a squared b? Let's break it down. Number first, what is the square root of 36? 6. A squared means I have 2 a's, and I have how many b's? 1. Anyone see a pair? The a's. So the a's come out, and what's left over? Where does the b stay? In the square root. So whatever's left over stays inside. So it works the same way as numbers. We just have to understand what a squared means, or a to the 5th means. Okay, so I want you to try this one. We'll keep it simple. So I'd like you to take the square root of 64a to the 3rd. 64a to the 3rd. What is the square root of 64? 8. Okay. And what does a to the 3rd mean? There's 3 a's. 1, 2, 3. Do you see any pairs? I see one pair. The pair comes out. The leftover stays inside. Okay, so adding variables doesn't really change up a whole lot. Let's try the square root of, I just want to make sure we haven't done this. Let's do the square root of 45 a to the 3rd b. Okay, 45a to the 3rd b. I'll do this one with you and then I'll give you one to try. So if I'm dealing with the 45, is 45 a perfect square? No, so I'm going to break it down, right? Give me two numbers that multiply to 45. 9 and 5. I don't see any pairs, so I'm going to keep going to 3 and 3. Do you see a pair now? Okay, so I have the 3. Before I write things out, though, because I like things to look neat, I'm going to deal with my variables. So I know the 3 is going to come out, and I know the 5 is going to stay on the inside. Everyone agree with that? Okay. According to the variables, I have 3 a's and a b. Do I have any pairs? I have a pair of a's. So my pairs come out. 3 times a is 3a. My leftovers stay inside. 5 times a times b is 5ab. Pairs come out, leftovers stay inside. Okay. You think you can try one? How about the square root of 132 x squared y squared? So the square root of 132 x squared y squared. Go ahead, Annie, you're up. (22 times 6 gave you 132. Okay. Okay, I'm going to stop you real quick. Fine. Did anyone use something other than 22 and 6 to start? McKenna, what'd you use? 66 and 2? 33 and 4? 12 and 11? Okay. Did all of you end up with the same prime factorization at the end, no matter what you used? Okay, you should. So I have a pair of 2s, and I have an 11 and a 3 left over. Okay. Perfect. Okay, so I have x squared, which means I have 2 x's. I have y squared, which means I have 2 y's. I see pairs. So on the outside are my pairs. 2 times x times y is 2xy. And my leftovers go on the inside. 11 times 3 gives you 33. Did we get that? Okay. I'm going to take silence as a yes. Great. Are we ready for homework?